Hello everyone, my name is Chihiro Dixon from Utah State University, and we are excited to share our article titled Automated Hanging Water Column for Characterizing Water Retention and Hysteresis of Coarse-Textured Porous Media. Water retention characteristics are one of the important hydraulic properties which describe the relationships between the volumetric water content and the metric potential of porous media. Water retention is hysteretic, which means that the water retention during the drying process and wetting process follow different pathways. Traditionally, water retention measurements were collected manually using various methods, including hanging water column, Tempe cells, and pressure plate. However, manual measurements are time-consuming because they involve stepwise metric potential adjustments and require wait time for equilibrium conditions. Therefore, our objectives was to design the automated system to measure the hysteretic water retention of porous media. This is our automated system that employs the hanging water column method. A laser distance sensor is mounted on top of a linear actuator, and it moves parallel to measure two vertical positions, which is the burette reference level and the funnel reference level. A Buchner funnel with ceramic plate holds the sample by maintaining the hydraulic contact with a pressure transducer and a burette through the tubing. The pressure transducer is located at the same height as the surface of the ceramic plate, and it monitors the metric potential of the sample base. The burette attached with another linear actuator induces a metric potential gradient by adjusting the burette reference level. It also collects excess water from the sample as the drying and wetting process progress. Sensors and the control system's components are mounted on the panel on the right. We used our CR1000 data logger, and the control algorithm was written in the CR basic language. The logger program is attached in the appendix of our manuscript. Let's go through the measurements. The measurements initiate from the complete saturation condition, where the burette water level is at 0 and is parallel to the bottom of the sample. Beginning of the automated measurements, the laser sensor collects two vertical positions, the Buchner funnel position and the burette position. The system waits for the equilibrium condition of the sample by monitoring the metric potential value. After reaching the equilibrium condition, the metric potential and the burette water volume are collected. The water volume is used to compute the volumetric water content. We now have a pair of volumetric water content and metric potential. The system then lowers the burette level to measure another pair at different metric potential. You can specify the stepwise increment in the program. The same procedures are followed, such as measuring the burette position and the pair of the metric potential and the volumetric water content under equilibrium condition. After completing the drying process, the same processes but reverse burette level control are used to conduct the wetting water retention measurements until the burette position comes back to the initial level. You can specify the number of repetitions of these drying and wetting cycles in the program. The system terminates at the lowest burette position of the final drying cycle. This completes the automated measurements. We then collect the wet sample from the funnel to measure the final volumetric water content by oven drying the sample. All volumetric water content value should be offset based on the final volumetric water content value. We highlighted that our automated system provided water retention measurements for the initial drying process and highly repeatable main drying and main wetting processes using the standard quartz sand at various particle size ranges. If you have any questions, please feel free to contact us. Thank you very much for listening.
Show me the Englishman who doesn't love the road. Show me the true-blooded Aggie from Utah who doesn't love the spot where the